Hello, everyone. Welcome to CXO Spice. CXO Spice is a platform for thought leaders to share their point of view on innovation and explain how to make it happen in real world. I'm your host, Helen Yu. Today's topic is intelligent factory. Our special guest is Amal Adgaonkar, Senior Director of Manufacturing at Microsoft. Hi, Amal. Welcome to CXO Spice.
Hi, Helen, and thank you very much for having me on the show.
So great to have you. So before we dive into our discussion on intelligent factory, could you share your background and your role at Microsoft?
Absolutely. I'm Microsoft part of the manufacturing industry team, and I lead our strategy and solutions for smart factories. I have basically a supply chain background, and I come from a manufacturing and aftermarket spares planning type of domain. But more and more as time goes by, as you probably know, the fields are merging, and what used to be separate areas of work are now an opportunity for us to solve it, jointly together. This is exciting times for us to be in manufacturing, especially for the younger generation. Historically, it's been that they have all these mobile phones, and they have Instagram and TikTok and whatever on their phones, and they come to a factory and it's like, wow, there is nothing. So that's changing. That's changing big time. And gone are the dark days, and now we have a lot of Gen AI and digital twins and simulations, and it's exciting times to be in manufacturing.
I echo that, Amal. Let's begin with our conversation with a level set. What exactly is intelligent factory, and how is it different from smart manufacturing?
Yeah, it's a great question. I think, we started the journey a few years back, if you remember, with Industry 4.0, and the whole talk was around connectivity, right? Let's connect to machines so that, we understand what's going on with these assets, be it products, machines, whatever. So it started off as remote connectivity, and then people said, oh, it's a smart device, which means it has, some awareness, some ability to respond to an input or a stimulus. But that has evolved into more and more. So these smart connected products, smart connected machines now are becoming more and more intelligent. So what that means is they now have an ability to reason, to adapt, or to perhaps bring context if they get an alert from a machine saying something's happened. Getting an additional bit of information into what's happening, why is it happening, what could be the adjacency or dependency, or what could get impacted further downstream in the process. These are all contextual pieces which, typically operators on the factory floor have struggled to, go across 20 different systems and log in here and log in there and figure it out. All this now is being brought together through this intelligent factory conversation to be able to have these machines respond. And one of the greatest evolutions in the recent times is this ability for these machines to actually speak in natural language to humans. The intelligence has reached a point where, for the last, 3-4 decades, we humans have been struggling to speak machine language. I mean, that's what coding is about, right? Programming was about, teach a human to speak machine language. Now it's the opposite. Now you have the machines speaking human language. How awesome is that, right? That's the evolution of the intelligent factories that we see.
So we have absolutely shifted from trying to understand how to use the computer or machine to let the machine understand us better and communicate with us.
That's right.
So building on that understanding, let's explore the practical outcomes. What improvements in productivity and worker satisfaction resulted from Microsoft's focus on connecting workers in intelligent factory?
That's a great question again, because we from a Microsoft perspective want to empower every person and organization on the planet to achieve more, and frontline workers, or our factory employees are front and center of the operations for any manufacturer. Building factory co-pilots for these workers is being a top opportunity that we see for Gen AI or infusion of technology for these workers, bringing them tools. Think about an operator needing instructions or to find out I have a particular CNC machine I'm operating. What's the optimal cutting speed I should go with for this job? Now, they would have to go to a manual, flip through pages, find out the information. Today, with factory copilots, they can just in natural language ask this question, and the AI engines, the Gen AI engines in the back, have the ability to look at their own specific, enterprise content, understand that information, bring that data back very quickly. So there is a tremendous improvement in the productivity and efficiency of workers by just having access to all that unstructured data, like data that sat in PDF files, in Word documents, in files and shelves on shelves, getting all that information. We can even OCR these paper-based documents, honestly, and bring that together. Now, this has implications in productivity, in quality, for example, understanding what's good quality, what's not, inspection processes, bringing AI tools as a sort of a co-pilot to an actual factory worker if they are doing some high precision inspection under a microscope. That can be a very tiring job for these people, honestly, doing day in, day out, looking under the microscope. Bringing vision capabilities or AI capabilities there from a machine learning standpoint for augmenting what they are doing, or avoiding double checks, or catching errors. This is a big opportunity, as well as in worker health and safety. Let's not forget, factory environment can be dangerous at some times, and bringing AI-based tools for understanding, let's say, chemical spills or hazardous objects in pathways, or using even the CCTV camera feeds, and anonymizing people, of course, but understanding if the operations are safe or not, are some great opportunities to actually help employees, and help create a better environment for the factory workers and employees on the factory floor.
Well, that's profound innovation. Thank you. And that's a great segue to our next topic, as a matter of fact. By the way, I came across your white paper, Enhance Innovation Agility with Digital Twins, and find it super impactful. So thank you. Let's
That's
unpack that here a little bit. And what exactly is digital twins? And then digital twins were coined by Michael Greaves back in 2002, I believe. And how is it different now, 20 years later?
Yeah, it's an area of great passion for me. I've been super excited about the whole evolution around digital twins. What started more than 50 years back, as the Apollo mission that NASA was involved in bringing astronauts back safely to Earth. I think the concept has evolved significantly since then, right? And very often we get asked, "Hey, what's this digital twin? What is it? How is it different than like perhaps a dashboard that I am, or using some digital representation?" There are a few areas where digital twins shine really well, right? So, firstly, it's the ability for remotely controlling assets. And all of us went through this pandemic, and one of the number one concerns that manufacturers had during the pandemic was, where are my machines? What are they doing? Are they working or not? Are they running or not? What's the efficiency? And I really don't want to go on the factory floor. I want to be able to sit securely, remotely, see this. So having this ability for remote visibility, remote control was like a top use case a few years back. And once you have a digital connectivity into asset, you can do things like rewind and replay, right? If something goes wrong in the factory, you can go back in time. Just like on a video, you could scroll back and scroll forward. You can see what happened, and then why did it happen, and then you can replay it and make it better, safer, faster, more efficient next time around. Once you have this digital twin, there is also an opportunity for doing simulations and what if analysis and a whole bunch of scenarios without actually changing anything on the factory floor. So the opportunity is that you can answer questions very efficiently if you have the digital twin representation. And all this leads to a new emerging area, which is referred to as digital verification and validation. This has been big in the area of engineering design, for example, but that concept is now coming into factory operations and products as well. So in summary, there are a lot of capabilities that digital twins can bring for a manufacturer. And as the new technology evolves, particularly around Gen AI, the digital twins are also evolving along with Gen AI, right? And it provides a great platform for manufacturers to infuse AI technologies into their digital operations. So what does that mean, right? There are a few areas where this can be really, really transformative, right? The first, of course, is the ability to converse with these digital twins in natural language. So just like you and I are talking right now, you could talk to a factory and you could say, hey, factory, how are you doing? How's your efficiency? Are there any problems? You can ask questions like these in natural language to a factory, which is, I think, phenomenal. I mean, I'm just super excited that we get to see a transformation like this in our lifetime that has happened with AI.
I
But
echo that. Yeah,
yeah,
echo
totally.
that.
And going beyond that, once you ask these questions, the factory is also able to respond. The digital twin of the factory is actually able to respond back to you with context, with this information, with reasoning over the data. So, typical knowledge that a worker would have after somebody worked on the factory floor for 30 years, for example, they have all the domain knowledge, all's going on. And you say, hey, Michael, what's going on in the factory? And Michael gives you an exact answer back saying, hey, this is what is going on, because Michael has the domain knowledge on the factory floor and so on. You can actually ask the factory a similar question, and the factory understands what's going on, understands the root cause of if something goes wrong, and actually responds back in natural language saying, yeah, my dryer on this particular line is actually down because XYZ happened on the factory floor. I mean, how transformative is that, right?
Mhm.
So this is the power of digital twins and the data foundation with Gen AI infused in it to be able to transform how manufacturing is now going to be going forward. So super
Yeah.
excited.
That's fascinating, right? I actually experienced digital twins firsthand at Microsoft Innovation Lab recently when I was there. So this, I totally echo what you just said, and just amazing to see the impact of digital twins. So let's look at practical applications. How has Microsoft Factory Digital Twins and MES on Azure help improve operations, reduce issues in manufacturing? Is there any measurable business outcome you have seen?
Absolutely. Um, let's start with, what is number one concern on the factory floor, which is typically around waste,
Mhm.
right? So the most obvious use cases, in addition to just getting visibility and alarms and alerts and so on, is customers will say, hey, can your solution help me reduce my waste, for example, in the production process? You might be, let's say, a company making bread or making cookies, for example, and you might, your most expensive ingredient probably in cookie process is the amount of sugar you consume. And if you really compare the amount of sugar you buy in a year and the amount of sugar you sell in your finished goods, there's typically a gap in those two. And understanding why is the gap, where can you investigate, where can you optimize production processes. Maybe you're losing some cookies in the baking process, maybe you're losing some dough, and understanding the losses along the way helps you improve your efficiency in the operation. So waste reduction in terms of material waste, productivity waste, like in terms of time or labor, these are all very important factors for a manufacturer to stay efficient and competitive. Perhaps the biggest metric that we track against, Helen, here is referred to as OEE. Your audience might be familiar with it, but it's referred to as overall equipment effectiveness. And it's a combination of a few things, right? It's a combination of availability, which means how much is this machine available to run, right? Is it down or is it running, right? Typically, the downtimes, drive the availability factor. The performance of these machines, which means are you running it at full speed that it's capable of, or are you running it slower because, if it's a packaging line or whatever, there's a performance aspect. And of course, there's quality, which means are you having defective products in there, or are you putting the best product in there? So the combined metric of these three together is referred to typically in the industry as OEE, or the overall equipment effectiveness.
Mhm.
But here's the cool part about it, right? Every bit of improvement that you can do for OEE, you're going to impact your profitability, by order of like 10 or 15. So it's like you're able to achieve more with the same investment in your assets. You're going to improve quality. So it's the same, sort of operations, but you are able to get a lot more good quality finished products out of your factory investment. So that productivity improvement is fantastic. And this is the power of the digital twins that it brings in. I'll give you some examples, maybe. We've been working with Mars, who makes, candies
Right.
and
Yeah.
Skittles. Everybody knows Mars. They've built digital twins on our platform to actually track the efficiency of their production process, of their packaging operations, making sure that they are packing the right amount of Skittles, for example, in every pack, and that way, these are high-speed packing machines. These, machines like to have a mind of their own. Sometimes they drift, to pack more or pack less or whatnot. So optimizing them, is something that digital twins do a really good job of, and making sure that you get the right amount of candy in every pack. And when you're making tens of thousands of these every hour, it becomes very critical for this. So a tremendous impact on profitability, what sometimes is referred to in the retail industry as product giveaway, to optimizing that parameter and making sure you have the right amount of product in right pack, is a use case that they have built on our platform. Some very large automotive companies, for example, also have invested significantly in the data platform that powers these digital twins. For example, Mercedes-Benz is another example. They have built this platform called MO360, where they're pulling in data from all different parts of their organization, from manufacturing, from sales, from design, engineering, so on and so forth, to create a single platform, which will then help power these analytics and data. So long explanation, but you get the idea that manufacturers are really excited about building this digital muscle so that they can achieve these use cases one after the other, on this digital twin investment.
Well, I love that the concept of digital muscle, right? When you when you have sugar and candy bars built into the complex concept of OEE, and that resonated with me. So thank you. Now let's shift gear a little bit. How does Microsoft Cloud for Manufacturing help manufacturers reduce their carbon footprint and achieve sustainability goals?
Yeah, sustainability is very important for Microsoft, and I'll give our own example. For example, Microsoft's goal is to be carbon negative by 2030 in terms of everything that we do. We definitely want to help manufacturers achieve their sustainability goals, be it in terms of manufacturing and factory floor, or perhaps in terms of design. For example, even take single-use plastics, for example, right? Shampoo bottles and whatnot. The design of the shampoo bottle, can you use 20% less plastic in that, and can you come up with a better shape that holds the structural strength of the bottle but uses less plastic? This becomes an engineering design problem, if you think about it. So there are different ways to achieve these goals, and Microsoft's helping customers in several dimensions to help them achieve their goals. The important thing we realized was, for any objective like this, you need to be able to measure your current footprint accurately, right? So I think the definitions around what scope 1, scope 2, scope 3, but the important thing is that manufacturers need tools to be able to measure their current carbon footprint, as an example, or energy consumption or whatnot. So once you measure something, you can of course improve on it. But if you can't measure, then you have a hard time, where do you start? How do you improve, right? That becomes a problem. So our priority one was to build these calculators and tools and bring it to the industry at scale so that they can start monitoring and measuring, and then they can create a plan to go improve and achieve their goals. So we have invested in what we refer to as Microsoft Cloud for Sustainability, and through which we offer these calculators for the industry to be able to feed their data, understand their impact, embark on several projects that lead to these sustainability goals, and then again track progress. And it's a very important initiative for many manufacturers, and Microsoft is fully committed to supporting them in their goals.
What gets measured gets done, right? I'm glad to hear about the calculator that helps people gain that visibility. So thank you. Let's move on to cybersecurity. Ransomware remains a critical concern for all manufacturers. So how does Microsoft ensure that the security and resilience of connected factory against cyber threats?
Yeah, I'm glad you're asking this question, because it is a top priority for us as well. Microsoft calls it security above everything else, and we have launched a secure future initiative within Microsoft to be able to prioritize security over any new feature development or whatnot. So if there's a security issue, all our engineering teams now have a very clear guidance to go fix that first before doing anything else. For manufacturers, sometimes they get caught up in their manufacturing operations and concerns so much that sometimes security becomes an afterthought, right? And this is a problem until they get hit with something like ransomware, which has been on rise in recent days. And then, literally everything you are doing comes to a grinding halt. What do you do in that case? And then, of course, it's better to be prepared and secure before you enter or have this kind of experience. So, particularly on the OT side, typically you'll see that the approach has been to air gap everything, meaning the IT infrastructure was separate and the OT infrastructure was intentionally sometimes kept separate in an air gapped environment. What that meant is no systems could talk to each other, nothing could connect to each other. But that is a problem for improving productivity or all these remote control and remote visibility and digital twins that we spoke about. So what is now happening is that assets are being connected, right? Customers are jumping into this OT connectivity wagon, but at the same time, they need to prioritize security so that they are not exposing those factory endpoints to the internet or the threat vectors who can then potentially attack through that channel and put the business at risk. And again, it's our job at Microsoft to bring tools and products and strategies for protecting our customers' assets. So we have some very differentiated solutions in the marketplace. We have a Defender for IoT, which is a product specifically built for OT. We have products like Sentinel, for security. We also have device and identity management tools like Intune and others that we bring in the Entra ID for access control. At the same time, we also have tools for compliance, like Purview, for example, which allows you to tag your data estate, and based on tags, you can decide what is confidential, what is not, what needs to be controlled in region, and so on and so forth. So we need to look at security as a continuum. Be it data at rest, data at transit, or data in compute. You got to protect assets, no matter where they are in this digital, ecosystem. And Microsoft's bringing it full force. It's a big area of investment for us. We are also aware that not just we using AI, right? Even the bad actors out there are also using AI to attack, right? So our job then becomes, it's not a deploy once and done type of solution. Our approach is to continuously monitor threats, continuously build solutions and products, continuously bring in the very best of AI to stay a step or two ahead of these threat vectors so that we can constantly detect and protect our customers' assets and our own assets. So this is really a top priority for Microsoft. Like I said, it's security above everything else. And through the Secure Future initiative, we will bring it to our customers out there.
Well, it's inspiring to hear that Microsoft takes cybersecurity so serious, right? They pretty much embed that into everything you do from development to deployment. So thank you.
That's right.
We can't wrap up any tech conversation without talking about generative AI. So could you talk about how combining generative AI and quantum computing in Data Lab is speeding up Unilever's ability for product innovation?
Yeah, I love that story and the work that Unilever has done in terms of innovation. Microsoft's investing very heavily in the quantum technology stack. Again, it's important to realize that it's a tech stack. There are a few pieces of this puzzle that need to be built out, like a Q-sharp as a programming algorithm, and the algorithms themselves have to be quantum enabled, so to speak. It's a combination of technologies. It's a combination of AI, generative AI. It's a combination of high performance computing infrastructure, right, which is specialized, dedicated compute platform. which can then simulate these quantum algorithms on top of it. So one of the most prime areas of research is this area of computational chemistry or material science, as you might put it. The computational chemistry, brings in mathematical models to figure out combinations of chemicals and stuff like that. So, for example, if you want to find out if a particular molecule dissolves in water or not, right, you can actually do this mathematically and answer this question, and that gives you the power to try, so many million different options, right? And what used to happen is, if you were to use conventional compute, you can solve it using conventional computing as well, but that takes a long or period of time, maybe months or years, to actually solve. I don't know, if you have 30 million combinations you want to try out, it's a lot of computational work that needs to go in. By bringing those models, the computational chemistry models, in the quantum sense, by creating quantum aware algorithms, you can actually run this in a much more efficient manner. I mean, you're talking days or weeks instead of years of computation. So you can literally try millions of different molecules and test them out. And Unilever has done just that, right? They want to introduce certain compounds or chemicals in their shampoo or washing powder, and they want to know if it dissolves or not in water. And to be able to do that through this quantum simulation, they're able to sort through a very vast opportunity space and narrow down the focus, again, using the power of AI. So it's not just brute forcing everything. You're bringing in intelligence to it for formulations and identifying, for example, different ratios of ingredients that go into these products, and sort of arriving at a better product for their customers worldwide. So it's a very inspiring story. We see a lot of power for quantum elements. It's early days, of course. This is a rapidly evolving area of technology. But to be able to infuse, the power of AI, high performance computing, simulation, and mathematical algorithms together in this to actually come up with better materials, better products, better chemistry to make our lives better is where the opportunity lies for all of us. So I'm really, really excited about this Unilever story.
Well, me too. So I can't wait to see what's coming out of that. That actually alone deserve another episode of CXO Spice. But in essence of the time, let's wrap up our conversation with an outlook. So what are you most excited about the new technology and trends that's relevant, shaping the future of intelligent factory? How is Microsoft preparing for these evolving needs?
Yeah, so the future is very bright in my mind, and I'm really excited to be in this field of manufacturing, because what used to be the North Star in terms of the Industry 4.0 revolution, and now perhaps getting into Industry 5.0, as some people are referring to it, we wanted to get into a more of a connected and then predictive and prescriptive environment, right? The North Star was, can machines be operated autonomously? Can they self-heal? Can they self-optimize? Can they diagnose problems by themselves and solve them? All that is becoming real today, right? In several use cases, in several areas, we are able to enable a feedback loop from these machines. We are able to understand, do trends analysis, predict problems before they happen, and then alert operators, before something goes wrong. All this AI-driven autonomous operations is one big, big area where you're going to see a lot of innovation, a lot of AI application, something that's very, very exciting. And Microsoft's investing very heavily in these AI technologies, Gen AI being just one of them. There are other cognitive services like vision, speech, language, and so on and so forth that we are investing in. The second big area that is very exciting, and I'm personally very excited about, is this evolution around robotics. So if you think of automation, robots have been around for a long period of time, but now, the evolution is from these special purpose robots to now more generic robots, sometimes referred to as humanoids. So they are like human equivalents, but they can be trained and programmed. They look like humans. They're like 5'6" or whatever. They weigh roughly the same like a human. They look like a human. They act like a human. They speak like a human. And they have now the haptic capabilities, the grip strength, the motion, all that is now being fine-tuned using the power of AI. so that these humanoids can be actually deployed on the factory floor to do some maybe hazardous tasks that humans didn't want to do, or go into high temperature, high vibration areas where, it's not very safe for humans to operate. These humanoids can be of significant help for us to go do this. So I think I'm just very excited that I'm able to witness this transformation in our lifetime. The investments from Microsoft in this area, be it large language models, be it small language models, to be able to run on the edge, the whole edge computing, the ability to connect to these data estates around the world and bring it together to make meaning out of it. These are really, really exciting times for us to be in this manufacturing industry. So I'm thinking the future is very bright. I'm so glad to be here at this point.
Yeah, I share that excitement with you, Amal. I actually saw quite a few cobots and giant robots at Microsoft Innovation Lab in Houston recently.
Awesome.
So thank you so much for sharing your insights and wisdom with us today on Intelligent Factory. Here are my 4 key takeaways. Number one, the shift to Intelligent Factory really highlights the integration of advanced technologies like AI, IoT, quantum, digital twins to achieve higher levels of automation and efficiency at scale. Number 2 is Microsoft initiatives in connecting workers within Intelligent Factory lead to significant improvements in productivity and worker satisfaction. This emphasis on connectivity and collaboration enhance operational efficiency, creates a more engaging work environment. Number 3 is the digital twins, right? Have significantly evolved, driven by technology advancement in AI, cloud computing. Microsoft has enhanced operational performance and issue resolution with the factory digital twins and MES on Azure. I love what you talked about, how you can use digital twin to reduce waste, production waste, and then you measure that through OEE. Really love the Mars story and candy sugar production story. So thank you. And then lastly, Microsoft is really serious about sustainability and security in Intelligent Factory. It's not an afterthought. It's something you embed in everything you do. This is just so inspiring, and thank you. I'm, like you, very optimistic about the future of Intelligent Factory, shaped by AI, quantum, digital twins, and robotic, right? And then thank you, Microsoft, for your dedication to making factories safer, more intelligent, and more connected. Thank you, everyone, for tuning in. Stay hungry, stay bold, and stay grateful.